Okay, this says select the choice that is a graph of the function. So we can just talk about the graph first and then see what answer matches it. Um, so if we have a rational function with factors in the denominator, these factors can either cross out with something in the numerator or not. So if they cross out, I'm going to write if factors cross out, or reduce. I'll just write cross out, even though there's probably a better way to write this. If the factors cross out, that implies that there was a hole there, and crossing out that factor will fill the hole. So if a factor is crossed out, let's say this was an x minus 2. I would cross that out with that. That means there was a hole at x equals 2. I filled it by crossing out that factor. Since that's not a 2, I can't cross it out. If they don't cross out, that implies an asymptote. So we have an asymptote at the values that make the denominator 0. So there's an asymptote, a vertical asymptote, at x equals 2 and x equals negative 3. Okay. So if I were to graph this, let's see here. 1, 2, 1, 2, 3. There's one. There's the other. Now we have to figure out what the graph looks like between and on either side. So the next logical step would be to figure out what the horizontal asymptotes are. Let's see if I can find a place to put this. I'll squeeze it over here. Horizontal asymptotes. You can determine the horizontal asymptotes by looking at the degrees of the numerator and the denominator. So if the degree of the numerator was greater, if there was more x's being multiplied up top, we call that top heavy. Okay, there's more, the degree is higher on the top. An example of this would be like f of x equals 3x squared over 2x. Okay, there's no horizontal asymptote in this case. You can either say there's a slant asymptote. When you take 161, you'll talk about slant asymptotes. But generally speaking, as we move to the left or to the right, we're approaching infinity. So for this class, we don't worry about that. There's no quote unquote horizontal asymptote. If it's bottom heavy, if the degree on bottom or the exponent on bottom is larger, like we have here, we have on top x to the first minus 4. If I FOIL the bottom, this is x squared plus or minus something. This is bottom heavy. If we have a bottom heavy rational function, the horizontal asymptote is y equals 0. So I will draw that. The x-axis is our horizontal asymptote. And the last case would be if it was even. If this was x to the x squared on top and x squared on bottom, even degree. And let me give you another example. Let's say I have f of x equals 3x squared minus 7 over 4x squared plus 27x. When the degree of the top and the bottom is the same, the horizontal asymptote is y equals, and it's the ratio of the coefficients. This would be y equals 3/4. Basically, if you think about it, if I put a really, really big number in for x, like a million, I'm basically going to have on the top 3 times a million squared minus 7 over 4 times a million squared. This is basically just going to be, when this all said and done, about 3 over 4. 3 million, well, 3 with 12 zeros after it, and a 4 with 12 zeros after it. So it reduces to just 3/4. So when the degrees are even, it's just the ratio of the coefficients. So in this case, here's where we are. The horizontal asymptote is y equals 0. So now we have to figure out, that might be enough to determine which equation is correct, but you also want to determine what the graph looks like on either side of the asymptotes. So I would start by plugging in a value between the middle asymptotes, between these two asymptotes. And I think the easiest value to plug in would be 0. Just to get an idea, this would help us maybe eliminate some of the choices on the graphs. This is 3 times, up top we have 0 minus 4, that's negative 4, over 0 minus 2, that's negative 2, times 3. This is negative 12 over negative 6. So it looks like I go through the point 0, comma 2. Let's see if any of the graphs have those characteristics, or if more than one have those characteristics. It's not choice A. We have the vertical asymptotes at, the vertical asymptote should be at negative 3, positive 2. So let's see if I can do, I'll do pen here. It's not this, because this is at positive 3, negative 2. It's not that one. This says the correct asymptotes, and it goes through 0, 2. So that looks good so far. This third choice has the correct asymptotes, but goes through 0, negative 2. That's not our answer. And this has the incorrect asymptotes, negative 2 and positive 3. So it looks like our answer, based on all the information we've figured out, is option B. And again, when you take 161, we'll analyze this stuff further so we can tell more. But for the purpose of Math 100, the most important thing to notice is the vertical asymptotes, the horizontal asymptotes, and then looking for one additional point to help figure out which graph is correct. And I think the best bet is to find the y-intercept.